Hello guys, welcome back to my YouTube channel Anveshana Academy. This is Dr. Manjunath Chennapgod. Dear students, in the previous class we discussed about what is conduction heat transfer and who explained the conduction heat transfer first. So, what is Fourier's law of conduction? What is the statement of Fourier's law of conduction? And what equation he has given to calculate the conduction heat transfer? In detail we have discussed. And also we seen some assumptions which are made by Fourier while giving the statement towards the conduction heat transfer. Dear students, come today we'll move towards next topic. That is sign convention for conduction heat transfer. Dear students, what I will do, I will take in a metal plate. To that metal plate, what I will do, I will try to supply heat. That heat is Q actually here now. That heat is going to transfer through this metal plate. Okay, this is having phase A and this is having phase B. Heat is going to transfer from phase A to phase B. Okay, that metal plate having any area that is represented as A and thermal conductivity K, thickness of the metal plate is dx and width of the plate is W and height of the plate is H actually. So the heat is going to transfer through across the thickness of the metal plate. So at high temperature phase, I will mark temperature as T1, then low temperature I will mark here as a T2, dear students. So what I will do to better understand, what I will do, I will take this thickness, I will assume it as a front view. Then what I will do, I will try to draw the diagram once again here now. The thickness I will take it, dear students. That means what heat is going to transfer from high temperature region to low temperature region. That is nothing but what? T1 to T2. When it is moving from T1 to T2 across the metal plate, there is some resistance. That resistance also I can show it in the thermal circuit. The same thing I will do here now, dear students. I will take the thickness of the plate or length of some authors, they will use length of the plate also. This one, okay, I will take it here now. So, dear students, you can see here. Okay, so at this point, I marked as a T1, right? I will take it here as a T1. So heat is moving from this end to this end. So that I will show it here now, this end to this end. The heat is moving from T1 to T2. That heat is moving in this direction, that is Q I have shown. That material having thermal conductivity, that is K. Then dear students, you can see now at starting point, I will call it as a X1. Then end point, I will mark here as a X2. So X2 minus X1, that is nothing but what? L, that is nothing but what? Thickness of the metal plate. Then heat is moving in this direction, right? So starting point of heat, that is point 1, the temperature at point 1 I will mark here as a T1, then temperature at end of the metal plate I will mark here as a T2, that is nothing but temperature at point 2. Then heat is moving through the metal plate, thickness of the metal plate, there is some resistance, that resistance I am going to mark here now. So that resistance is nothing but what? R, the value of R is equal to L divided by Ka, dear students. Then heat is moving in this direction from T1 to T2, so I will mark here as a Q, dear students. Then one thing you can observe, dear students, when the heat is moving, right? When the heat is moving from point 1 to point 2, right? So the temperature is decreasing, that you can see here now. If example, I will take a temperature at this point, it is 100 degrees Celsius. Then I will leave it for 5 minutes or 1 minute. You can take 1 minute. Then temperature I will measure at this point, that will be around 80 degrees Celsius. That means what? Temperature is decreasing. So again I will leave it for one more minute. Then temperature, I will measure temperature at this particular point. That temperature may be 60 degrees Celsius. Then I may measure the temperature of the metal plate at this particular point after 1 minute again. Then temperature may reach to 40 degrees Celsius. That means what, dear students, from this point to this point, the gradually temperature is going to decrease along the thickness of the metal plate. As the metal plate thickness is going to increase, the temperature is going to decrease during the heat transfer. That decrease is nothing but what? Negative or minus. The decrease in temperature along the thickness of the metal plate is the minus or negative sign. To show that decrease in temperature, what we are doing? We are using the negative sign in the equation. This concept is given by what? Fourier again. Okay, so how it is, dear students, now? As I told, dear students, you can take vertical axis time and x axis you can take a thickness or length of the plate. So as the temperature is decreases, you can, okay, as the length here it is, right? Here 1, 2, 3, 4 like that you can take. Temperature here high, it is 100 degrees Celsius, example 80 degrees Celsius, 60 degrees Celsius or 40 degrees Celsius and 20 degrees Celsius. As the thickness of the plate or wall is going to increase, the temperature is going to decrease. The decrease in temperature we are going to represent with a sign. That sign we can call it as a minus sign or negative sign. How it is negative sign? How best we can understand? I will take one example. I will take some readings and I will try to explain you, dear students, for this sign convention of metal plate. So dear students, what I will do, I will take a metal plate. So I will take a metal plate. Through that metal plate, conduction heat transfer is going to take place. Dear students, what I will do, at this particular point, I am going to measure one temperature at distance x1. So temperature I will mark here as a T1. So the next, 1 minute, I will measure temperature at point 2, that is x2, that is nothing but length 2 at metal rod. The temperature I will mark here as a T2. Then I will measure temperature at this particular point x3. The temperature I will mark here as a T3. Then next, I will measure the temperature of the plate. I will measure the temperature of the plate. 1 minute. At this particular point, the temperature I will mark here as a T4. Dear students, here is the heat source. Here is the 1 minute. Here is the heat source, dear students. That means what? Heat is moving in this direction. Heat is moving in this direction. That heat I can mark here as a Q. Heat is moving from left to right. That means what? When the heat is moving in this direction, as the length of the metal rod is increasing, the temperature is going to decrease. To understand that, what I have done, I have taken a sample readings here, dear students. So point 1, at point 1, that is x1, that here you can take it here now. It is 25 mm. Then here it is the distance between x1 to x2 is 25. Here to here it is 25. Here to here it is 25, dear students. Then total length is 25 plus 25 plus 25. The total 100 mm length is there. The length of the metal rod is 100. I have taken here, dear students. You can take it mm itself. Mm or meter, it's up to you. So now, what I will do, I will try to draw the graph. Dear students, as the length of the metal rod is going to increase, the temperature is going to decrease while transferring heat from high temperature region to low temperature region. That decrease in temperature we are going to represent with a sign, that is minus sign. How it is with help of this reading, with help of this sample reading, I will try to explain you, dear students. So now what I will do, I will take a graph, dear students. So I will try to read the definition, but you can see here, right, when it is a heat source here, right, obviously here will be the more temperature. Then little bit you can move forward. Then if you are measuring temperature at this point, this temperature is lesser than this one. Why so? Because the temperature at this particular point is near to the heat source, hence it is more temperature. Little bit you come forward, then temperature you measure here, that is lesser than T2. Like that, T4 you can measure the temperature of T4 at this particular point is lesser than T3. The same thing I have taken reading samples here now. Dear students, you can see at point 1 or x1, what is the length? That is 25. What is the temperature? 80. So for that purpose, what I will do, dear students, I will x-axis I will take length. X-axis I will take length. Then y-axis I will take temperature, dear students. I will take temperature. So now okay, fine. Now what I will do, dear students, you can see here now. I will mark the distance now. What is the distance from here to here? So it is a 0. Here to here I will take 2 columns here now. It is what? x1. x1 is equal to 25. The next I will mark here. Here it is 50 mm. That is 25 plus 25. Here it is a 75 mm. And here it is a 100 mm, dear students. It's for my reference. This is what length that I have marked. That is length x1 to x4. Okay, fine. Next, I will mark here temperature. Temperature, how I can mark, dear students? It is 20. And here it is 40. Here it is 60. And here it is 80. And here it will be 100, dear students. Okay, now what I will do, I will draw the graph now. I will draw the graph, how it is that you can see here now. Okay, so now at x equal to 25, what is the temperature? That is 80 degrees Celsius at x1. This is first reading, right? I can call it as a x1. At x1 is equal to 25. At x1 is equal to 25, that is the starting point. What is the temperature? That is 80 degrees Celsius. At x1 is equal to 25, the temperature is 80 degrees Celsius. That I will mark here, dear students. That is my point. 1 minute. Okay, this is equal to how much? It is 0.1. Okay, that is first point. Next, I will go to the next point, that is x2. x2 is nothing but what? My t2. So x2 is equal to 25. Again, 25 plus 25, that is 50. x2 is equal to 50. What is the temperature? 60. So x2 at 50, what is the temperature? That is 60. So I will mark here, dear students. I will mark here. Okay, so that is what? x2. Similarly, you come to the third point, x3. Again, 25 plus 25 plus 25, it becomes 75. I will mark here as 75. Then what is the temperature at 75? It is 40, dear students. I will mark here now. That is 40. Next, similarly, go to the fourth point. What is the temperature at fourth point? Example, it is going to decrease, right? So the same thing I am writing. At x2 is equal to 25. That means what? 100 total point. Then what is the temperature? That is 20. I will mark here now. So then I got an points. Okay, then what I will do, dear students, I am going to draw a line. That line you can see here. This is a straight line. Just I am drawing roughly. It is a straight line. So I am going to get a straight line. Then what I will do, dear students, I will draw one vertical line and then I will draw one horizontal line. So what is vertical line? You can see here now. So vertical, I will take any point, 2 points. I will take this point and I will draw one vertical line up to here. Then I have drawn vertical line. Then what I will do, dear students, I will draw one more line horizontally. I will draw one more line horizontally. This is point 1. This is the point I have taken. This point and this point I have taken. 2 points I have taken. Whereas this one, point 1 to vertical, you can see 60 minus 40. So what is 60 minus 40? That also you can see here now. So that is 60 minus, that is 20 only. Yes, 60 minus 60 minus 40. Okay, how much you are going to get? That is 20. Okay, so then that is nothing but what? Can I mark here as a D? 1 minute. Here, what is this? Change in temperature, delta T you can write, or you can write it here dt. dt is equal to how much you got? 60 minus 40 is equal to 20 degrees Celsius. Then it is vertical. Then horizontally you can see, dear students, there is a distance or is length of the metal plate. What is that? So here it is 75, here it is 50. 75 minus 55, what you are going to get? You are going to get the thickness of the plate. You can take it as a L or dx. I will take it here dx, that is equal to how much? 25 mm, dear students. Here it is a degree Celsius. Okay, then with the help of this data, what I can do? I can draw the slope. I can write the slope. What is slope now? Slope is equal to vertical value, that is dt, by horizontal value, that is dx. What is the value of dt? That dt is decreasing, that is what? 20 degrees Celsius. Then what is the value of dx? That is 25 mm is there, that you can convert it into meter. So that is nothing but what? How much? It is 0.025 meter. Then that is meter. Then what is the unit here now? So that is degree Celsius per minute. That you can see the graph, dear students, as the length of the metal rod is going to increase, the temperature is going to decrease. That decrease in temperature represented with a sign. That sign we can call it as a negative sign. Hence what will happen, dear students, now here the temperature is going to decrease. The decrease in temperature, 1 minute, the decrease in temperature we are going to represent, that is negative sign, please. Okay, that's gone. Negative sign. That this decrease in temperature is represented by with a sign. That sign is negative, dear students. This is how to draw the graph and how we can understand the negative sign of the Fourier's law. Dear students, one thing, with help of Fourier's law, what we can do, we can calculate the thermal conductivity. How it is that you can see here now, dear students. We know already we know conduction heat transfer equation for Fourier's law. What is that? That is Q is equal to minus K into dt by dx. And also I explained already the terms which are there in the conduction heat transfer. That is K, thermal conductivity, A is the area, normal area, that is perpendicular area, dt is the change in temperature, that what we have seen already, dx is the thickness of the metal plate, T1 and T2, that is delta T. Then thickness of the plate, some authors they will take D, some authors they will take T, some authors they will take dx, some authors they will take L also, that is what dx. Okay, thermal area is A is area, that is what. So here with help of this Fourier's law of conduction equation, I can calculate them K. How it is then? I will shift this term. Dear students, you can see here now. Okay, so now I will try to take the value of Q outside. So how K outside? How it is? K is equal to, I will leave minus sign here now. So Q is equal to, K is equal to Q divided by A into, what is next? K is equal to Q divided by A. The next it will go that side, that becomes what? dx divided by dt, dear students. So the same thing I have written, K is equal to Q by A dx by dt. So if by modifying the Fourier's law of conduction equation, what I can do, I can calculate the thermal conductivity for the given metal rod. This is what? Thermal conductivity. What is the unit for thermal conductivity? How we are going to get here, dear students? What is W? That we know already, watt. Then what is unit for area? That is meter square. I will write it here now. What is the unit for dx? That is meter. That is thickness of the plate. Then what is temperature? That is degree Celsius we can take, or Kelvin you can take. And so here you can see, dear students, here it is meter square, it is meter is there. Then meter square is going to cancel. Then what we are going to get? We are going to get watt for meter degree Celsius, or else if you are expressing temperature in terms of Kelvin, then you are going to get watt per meter Kelvin is the unit for the thermal conductivity. Hence what we can do with help of Fourier's law, Fourier's law of conduction equation, we can calculate the thermal conductivity for the given material. Okay, fine. Now what are the application of this Fourier's law? Yes, building insulation will require Fourier's law of conduction. Then designing heat exchangers, yes, Fourier's law of conduction is required. Then electronic cooling, whenever we are designing electronics items, right, there is a heat transfer is there. To determine that heat transfer, we require Fourier's law of conduction equation. That is what? Conduction heat transfer. Wherever conduction heat transfer is there, we require Fourier's law of conduction. Then it is required in material processing. It is required to calculate the geothermal energy. There also the conduction heat transfer will be there. To calculate the amount of heat transfer, we require Fourier's law of conduction. Okay, so now, but when it comes to this Fourier's, it is having some drawbacks. Some drawbacks we can say, or some limits we can say. What are the limits, dear students? You can see here are some Fourier's law limitations. What are those? This is not applicable for the transient heat transfer. It is the Fourier's law is only for the steady state conduction. Steady state conduction or steady state condition. It is not applicable for transient heat transfer. Steady state means what? The temperature variations will remain same at any interval of time. But if the temperature variations is there with respect to time interval, that is nothing but a transient. But that for that particular applications, we can't use this Fourier's law. That is one limitation, dear students. And it is inaccurate for any isotropic materials. It is the for other materials, if that material is having variable thermal conductivity, then we can't use this Fourier's law of conduction in that particular case. Then we can't. It is now microscopy, any nanoscale you can take, any nanoscales you can take. The law accuracy is not so much. If you are taking small nanoscale, right? If the heat transfer is happening there, in that particular case we can't apply this Fourier's law. Then last one you can see radiation heat transfer. This Fourier's law of conduction we can't use for the radiation heat transfer. I mean, we can't calculate the radiation heat transfer with the help of a Fourier's law or equation. That is also one of the limitation, dear students. Okay, I hope you understood the today's lecture. If you really understood, do like and comment. Thank you.